Hey everybody, welcome back to the Chem 107 video lectures, and in this particular lecture we're going to be talking about Chapter 30, Lewis dot structures. Now, Lewis dot structures to me are super fun. I really enjoy this part of chemistry because it takes something that is kind of abstract and makes pictures out of it. The guy, I always do that. Okay, the guy responsible for coming up with Lewis structures, his name was Gilbert Newton Lewis, and he did a lot of work with acids and bases. Okay, but he developed this so that he could actually understand kind of the elements and how compounds work, so that he could apply it to something a little more big, a little more hugelier, biglier. I don't know. So he took this simple concept, and probably Lewis dot structures are probably more widely known than what Gilbert Newton Lewis did spend his whole life doing, which was talking about acids and bases. So there it is. You become famous for things that you don't necessarily want to become famous for, or weren't trying to do. Anyways. So basically what we're doing is we're representing elements in compounds using symbols and dots. Okay? Now the dots in a Lewis dot structure represent the electrons. Now, it only takes a second for us to think, why does it have to be the electrons that are being represented? Well, that's right, because the electrons are the things that govern the chemical properties and physical properties of elements. The protons and neutrons, we can't manipulate them. So it only becomes the electrons that we care about for the most part. Okay? And so I'm going to have you take a minute, and I'm going to have you write down these rules right here. Okay? Or you can print them off on the printer. And then once you do that, I am going to go to the periodic table, okay? Because we're going to talk about elements and ions. Okay? So we'll go here, and then I will I'll erase all the writing here from some previous thing. So here's what we're going to do. Okay? Now, before we even get started, one of the things that we want to be able to do very easily is count valence electrons. Okay? And many of you have already figured this out, because there's the shortcut method of doing electron configurations by taking the noble gas and then picking it up here. But if that doesn't work, all we do, we're going to ignore these guys and these guys down here. But here's what we're going to do. I'm going to take these, and I'm going to number them. 1, 2, 3, 4, 5, 6, 7, 8. And because I numbered them 1 through 8, that numbering system gives us how many valence electrons there are in each of those elements in that particular column. So anything in this column has 1 valence electron. Anything in this column has 2 valence electrons. And notice the group number up here has that. And then we skip 10, and so because it's 10, it's a neat little mathematical thing. And so that means that this is the 13th column, but it has 3 valence electrons, and then 4 valence electrons, 5, 6, 7. And the only exception to that is helium, because helium is in the first energy level, or the first shell, and you can only put 2 electrons in that first shell. And so because we can only put 2 electrons, it has a full shell, a stable shell with only 2 electrons there. So the 8 really applies to neon right here. Okay? But nonetheless, if we can count valence electrons, we can draw Lewis dot structures, and not only that, but we can draw the Lewis dot structures of ions. And so here's what we're going to do. Let's take, for elements, let's take any element in the blue or the yellow. Okay? Okay, think of any element that has the atomic number 15. Any element, atomic number 15. Okay, so I'm going to pick phosphorus. Okay, that was a joke because phosphorus is the only element that has atomic number 15. Okay, I know somebody out there laughed at that. Maybe many of you didn't, but somebody did. And so here's what I'm going to do is I'm going to represent the number of valence electrons, because again, the valence electrons are even more important than the core electrons. Those are the ones that we can manipulate and move. And so I'm going to represent this. And so how many valence electrons does phosphorus have? 1, 2, let me make that a 2, 2, 3, 4, 5. Okay, so I'm going to put dots, 1, 2, 3, 4, 5. And so that is the Lewis dot symbol for phosphorus. It has 5 dots around it. Now, let me see if I can draw this a little bit better. 2, 3, 4, 5. Okay, so notice there's a pair here and then 3 that are not paired. Okay, that's on purpose. Okay, so all the rules of filling and electron configurations and things like that. Okay, that's how it works. Okay, let's do one more here. Okay, so for chlorine. Okay, chlorine. And again, when I draw chlorine, I do C, capital C, and then a script L so that I'm not confused between CL and C capital I, like iodine. And so chlorine, we can count, has 1, 2, 3, 4, 5, 6, 7 valence electrons. Or I can look here and, hey, 17, so that must be 7. Okay, and so now I'm going to do a Lewis dot symbol for this thing. So that's 1, 2, 3, 4, 5, 6, 7. Okay, notice I try to pair them after 4. Okay, I start on the right-hand side. You can start anywhere, but I always pick the right-hand side. And then I do one on the right-hand side, one on the bottom, one on the left-hand side, one on the top. And then I do one on the right-hand side. So I just keep going around. Okay, a little story about that is when I was playing, when I was in gym class in my elementary school, we played mat ball. Okay, and so mat ball is like baseball. There was a mat here, and a mat here, and a mat here, and a mat here. And so in order to score, you had to go around the bases twice. So I just say play mat ball, until you run out of bases. The number of bases that you have to go is the number of valence electrons, right? So you go 1, 2, 3. You start here, and you go 1, 2, 3, 4, 5, 6, 7, 8, and then you get home, and then it's good. Okay, so anyways, that's how I kind of tell people, right, play mat ball. Now for ions actually become a little bit easier to manage here. Okay, so let's talk about oxygen. Oxygen has 6 valence electrons. I'm going to draw its symbol, and then I'm going to play mat ball. 1, 2, 3, 4, and then 5, 6. Okay, so I got 1.5 times around the bases. Okay. And so now, in order to complete the octet, how many is octet again? 8. So how many electrons? It becomes a visual way to see how many electrons it needs to gain. Well, it's going to gain 1, 2 electrons. Okay. Now, in order to represent this as an ion, we're going to put it in square brackets, and then on the outside, I'm going to put a 2-. Okay. So we can do this with, let's say, magnesium, Mg. Okay, magnesium. So play mat ball, 1, 2. But magnesium wants to have 8 electrons. It loses 2. It's a metal, so it loses 2 electrons. So it's going to go back to neon. So in order to represent that, we take and we get rid of 1, and we get rid of 2 electrons. Now we've made an ion out of it. Any ion. Any ion that you make has to have brackets around it. And now what was the charge? Well, we lost 2, so it's going to be 2 plus. Okay? Hopefully your pluses look a little bit better than that one. Okay? So ions are represented with brackets, and we represent the number of electrons with dots, just like in Lewis dot symbols. Now, let's see if I can get back to this thing here. Okay. Now the fun part is we're going to do Lewis dot symbols for covalent compounds. Okay. And this is kind of fun. So again, here are 4 steps. Okay. And let's do this again on a periodic table. So pause the video if you need to, write those 4 steps down, and then I will make sure, here, I'll even number them. 1, 2, 3, and then 4 is check your work. So now we'll go back, okay, and we'll go to a periodic table. Okay, here's a periodic table, and oh, that's not the periodic table that I want. I want the one that we were just using, which is this one. Okay, same periodic table. Okay, and so let's draw covalent compounds. You ready? So what if we have something like H2O? Okay, step 1. Step 1 is to count valence electrons with all of these atoms. Okay, all these elements. So hydrogen is here. It has 1 valence electron, and there's 2 hydrogens. So that's 1 valence electron times 2 plus, let's see, oxygen, H2O. So oxygen is here, and that has 6 valence electrons. So that's 6. So the number of valence electrons, 1 plus 2 is, 1 times 2 is 2, plus 6 is 8. Okay, so what we have to do is we have to do something with 8 valence electrons. So I'm gonna write that over here off to the side. Okay, and now the second step is to draw a skeleton structure. Now, a skeleton structure shows how all the atoms are connected together using lines. Now, this line right here, that is a bond, and it is a covalent bond, right? And so that's how it's bonded together. Okay, it's pretty cool. Okay, now the next thing we have to do is we have to fill the octet. Octet, how many electrons? 8 of all the atoms. The only octet that we don't fill is hydrogen, because how many valence electrons does hydrogen want to have? Remember, hydrogen is special. Hydrogen is here, so normally we have 8, but hydrogen is going to go here, and it only has space for 2. So hydrogen here, because this is a covalent bond, has already shared its 2 electrons. A covalent bond is 2 electrons that is shared between the atoms. Okay? And so this hydrogen already has 2 electrons. This hydrogen already has 2 electrons. What we don't have is oxygen. And so if this has 2 electrons and this has 2 electrons, that means, remember, we're trying to get to 8. And by drawing the bond, we've used 4. So we have 4 electrons left. Okay, sorry, 4. Okay, so that means we have 4 more to put somewhere. So I'm gonna play map ball again. I already have 2 bases are full, so I have to skip here. So I'm gonna put 4 around oxygen, and now in a different color, oxygen has all of these electrons. And look, it has 1, 2, and then the bond counts as 2, so that's 4, 6, and then this bond is 2, so that's 8. Hydrogen has its filled valence of 8 electrons. Okay, let me do another. Okay, I'm going to follow the same steps. Okay, so we're gonna do let's do CCl4. Okay, so this is carbon and chlorine. Okay, so how many carbons are there? So this is step one. Step one, how many carbons are? Carbon is here, so it's 1, 2, 3, 4. It's also in column 14, so we know that this is 4. So it's 4. And then chlorine is here. It's in column 17, so it should be 7, but I'm going to count just to make sure. So it's 1, 2, 3, 4, 5, 6, 7. Yep. So there's not times. We're going to add valence electrons. Okay, so it's 7. And then this means there's 4 chlorines there, so that's times 4. So it's 4 plus 7 times 4. So 7 times 4 is 28. So this is, here we go. So this is 32 electrons. You know what I'm going to do? I'm going to pull out more white space here. Okay, so we have CCl4, and it has 32 electrons. Okay, now we draw a what we call a skeleton structure. That skeleton structure has carbon in the middle, and then chlorine around the outside. Okay? So now, how many electrons have we used? That was the second step. How many electrons have we used to make that skeleton structure? Well, each line represents 2 electrons. So that's 1, 2, 1, 2, 1, 2, 1, 2. So we have used 8. So 32 minus 8, we still have 24 electrons to use somehow. Okay? So let me do this. So 24. So the point is now step 3 says fill the valence or the octet of each of the atoms. Well, chlorine wants to have 8. The only one that doesn't want to have 8 is hydrogen. So none of this special stuff. So chlorine. Let's see. So that's 1, 2, 3, 4, 5, 6. And remember, the line counts as 2. So chlorine has 8. And so now we know 1, 2, 3, 4, 5, 6. And then chlorine, and then the line counts as 2. And then we do 1, 2, 3, 4, 5, 6, and the line counts as 2. Then we go 1, 2, 3, 4, 5, 6, and the line counts as 2. So chlorine has 8. This chlorine has 8. This chlorine has 8. And this chlorine has 8. Okay? So everything has 8 around it. So this is the checking step. Okay? Everything has an octet. Now the last one is this carbon. We haven't done anything with it. Now remember, this is the fun part. This carbon is sharing its electrons with chlorine. So these 2 electrons here, and then those 2, and then those 2, are not only chlorines, but they're also carbons. So these 8 electrons are actually also carbon's electrons. So this has 2, 4, 6, 8. So here's the thing. Everybody's octet is satisfied and filled. So I know I've made the correct Lewis dot structure. Now, you've waited through 18 minutes of this video. Here's the thing, is that when we draw Lewis dot structures, this is pretty similar representative of what atoms look like. We use Lewis dot structures to do general chemistry all the time so that we can see how atoms and molecules react. And so here, those 6 electrons, the fact that there's 6 electrons out here, that tells us something about chlorine and how chlorine works. The fact that there's 4 chlorines around this carbon gives us information about the chemical and physical properties of this compound. And so there's so much information wrapped up in doing things like this that this is why it becomes important. And this is why Gilbert Newton Lewis is probably more famous now for his Lewis dot structures than he was for his acid-base theory. So I know that this was a long slog through a video, but there was a lot of information in here, and we're going to practice this in class a lot. So I hope this clears it up, and have a great day.